This video is the second part of the polynomial division lesson, and so let's keep going with what we were doing. If you haven't seen part 1 yet, you need to stop and go back to part 1. On page 3, up at the top, the problem that is B, we are going to do n cubed minus 8 divided by n minus 2. Now notice we have the cube term, no squared term, no n to the first power, and then we have the n to the 0 power. So when we write the divisor, we need to fill in our zeros. So we have n cubed plus 0n squared plus 0n minus 8. In our divisor, we do have every term represented, so we just write down n minus 2. Okay, and then we look at this and this. How many times does n go into n cubed? And the answer is n squared, which we write over the squared column. Then we multiply n squared times each of these, and we get n, let me do that in red, n cubed minus 2n squared. And then we change our signs so that we can add, and we get the n cubes go away and we get 2n squared. Then we bring down our next term. How many times does n go into 2n squared? And it goes in 2n. So we multiply 2n times n to get 2n squared, and then 2n times negative 2 to get minus, make that 4. n. And then we change the signs, and then we add, and our n squared terms go away, and we're left with 4n. So we repeat the process. N goes into 4n 4 times. Multiplying 4 times n gives us 4n, and 4 times negative 2 gives us minus 2. And I forgot to bring down my negative 8 here. Okay, so 4 times n gives us 4n, and then we have minus 8. We change the signs and add, and we have no remainder. So this is our final product, and I'd like you to check that by multiplying using the box method. Now let's look at an example where the divisor is missing a term. In this problem, we're going to demonstrate how to handle a divisor that's missing a term, and also how to handle when you have a remainder that is not 0. So notice in our dividend we have every term represented, but in our divisor we're missing the h term. So when we write this out, we're going to write h squared plus 0. Don't forget your 0. It's not the same thing as just plain h. And so that's what your problem looks like, and I'd like you to go ahead and work it. Pause the video and work it and practice what you've learned. Okay, I'm going to work this rather quickly. H squared goes into h to the 4th, h squared times. So we're going to come to the h squared column and write h squared. And then when we multiply h squared by each of the terms, we get h to the 4th plus 0h cubed plus h squared. Changing to subtraction and adding, we get negative 4h cubed plus 3h squared, and then we bring down an h. H squared goes into negative 4h cubed, negative 4h times. So we multiply and we get negative 4h cubed plus 0h squared minus 4h. Change the signs. Add. And bring down the 1. Okay, do this again. H squared goes into 3h squared 3 times. Multiply 3h squared plus 0h plus 3. Change the signs. And add. And we get 3h minus 4. Okay, so we have a remainder of 3h minus 4. We're done with our division because 3h is smaller than h squared. H squared does not go into 3h. So our remainder, I'm going to just write it as a remainder here because I'm out of room. Remainder 3h minus 4. So let me write the whole answer over on our free space. Our whole answer is our quotient h squared minus 4h plus 3, and then we add our remainder 3h minus 4 as our numerator and our original divisor. We don't need that 0 term anymore. H squared plus 1 becomes our denominator. So whatever's out here becomes our denominator of our under our remainder, and we don't have to write that 0 term. So this is our final answer. And to check it, you would multiply h squared minus 4h plus 3 times your divisor, h squared plus 1, and then you would add your remainder, which is 3h minus 4. So let's go ahead and do that, and we'll use the box method to do our multiplication. So we set up our box using the terms here for our column headings and the terms here for our row headings. And then we multiply and put the products in each box. And when we do that, notice the diagonals are no longer like terms, but we can still go ahead and combine like terms as we go. So we start with h fourth. There's only one h4 term, there's only one h cubed term, so let's write those out. We get h to the 4th minus 4h cubed. And then there's 3h squared plus h squared. That gives us 4h squared. And then there's only one h term, that's minus 4h plus 3. So our multiplication here is this. But we still need to add 3h minus 4. So we're going to do that right here. Plus 3h minus 4. We're going to add those. And what we get is negative 1 here, h here, and then 4h or negative h, 4h squared, negative 4h cubed, and h to the 4th. So that should match here. We have h to the 4th minus 4h cubed, 4h squared, minus h, and minus 1. So our work checks. Now let's do a problem that requires us to use our favorite thing, fractions. But before we do that, I'd like you to try it. Look on page 5 of the notes and work number 3. Turn back to page 3. We are going to work problem D. So I've written it out here. Let's go ahead and do the division. 6a goes into 6a cubed, a squared times. So we'll write a squared, and when we multiply it, we get a squared times 6a is 6a cubed plus 12a squared. Change the signs and add, and we get 8a squared plus bringing down the 13a. So now we say, how many times does 6a go into 8a squared? Well, that's not so obvious, so let's go ahead and work that on the side. We want to know how many times 6a goes into 8a squared. Well, we can do the exponents easily enough. A squared divided by a is going to just be a. But then we're left with 8 6. So we know that 2 goes into 6 3 times, 2 goes into 8 4 times. So our result is going to be 4/3 a. So up here goes 4/3 a. So now we need to multiply 4/3 times 6a, and we get, let's do that over here, 4/3, and I'm going to put the a in the numerator, times 6a over 1. The 3 goes into the 6 2 times, and we have 4 times 2 on top is 8. 8 times a is a squared, and we have 1 on the bottom, so that's just 8a squared. And that's what we wanted it to be. So 4/3 a times 6a is 8a squared. And now what's 4/3 a times 12? 3 goes into 12 4 times. Multiplying the numerators, we get 4 times 4 is 16a, and the denominators are 1, so we just write 16a. Now we change the signs and add, and we get 13a minus 16a is negative 3a, and bring down our negative 6. Okay, and then how many times does 6a go into negative 3a? I want you to pause the video and see if you can figure that out. Okay, so we want to know how many times 6a goes into negative 3a, and we get, so we have to do negative 3a on top, divided by 6a. The a's cancel, and we get negative 3 6, but we know that 3 goes into 6 2 times, so we actually get negative 1/2. So here we write minus 1/2. And you'll see minus 1/2 times 6a is negative 3a. Negative 1/2 times 12 is negative 6. And when we change the signs and add, we get 0, so we have no remainder. So our answer is a squared plus 4/3 a minus 1/2. Okay, let's turn to page 4, and we are going to work a rectangle problem. In this problem, we are given a rectangle, and we're told that the area is a polynomial, x cubed plus 4x squared plus 8x plus 8. We're also told that the width is x plus 2, but we don't know the length. So the length we know that the length is, for a rectangle, area divided by width, and we know that because length times width equals area for a rectangle, and when we divide both sides by W so that we get length by itself, then we end up with length equals area divided by width. Okay, so let's go ahead and do that division. What we're saying is that our area is x cubed plus 4x squared plus 8x plus 8 divided by our width, which is x plus 2. So that's the problem we're going to work. We're going to rewrite that with the dividend under the division sign and the divisor outside of it so that we can perform long division. So here's what the problem looks like after we've done that. What I want you to do is pause the video and go ahead and do this division and then come back and check your work. Okay, x goes into x cubed, x squared times. X squared times x is x cubed. X squared times 2 is 2x squared. Change the signs and add, and we get 2x squared, and then bring down the next term. X goes into 2x squared 2x times. Change the signs and add, and we get 4x, and we bring down the next term. And then x goes into 4x 4 times, and we get a remainder of 0. So the answer is that the length equals x squared plus 2x plus 4. And how would you check your answer? You would use your multiplication, or length times width equals area. So then you multiply your length, which is x squared plus 2x plus 4, times your width, which is x plus 2, and you should end up with what you started with for area. And so that is it for 13.6 and 7 polynomial division.